Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in this lecture. Today we discuss about our next heterocyclic compound thiazole. Thiazole. Thiazoles are five-member ring containing three carbon atom, one sulfur atom and one nitrogen. Thiazole. We discussed thiol in previous lecture, which has only one sulfur atom as heteroatom, but here two heteroatoms, sulfur and nitrogen, both are present. Then it is known as thiazole, and two types of thiazole are known according to position of second heteroatom nitrogen. Second heteroatom nitrogen, there are two thiazoles are known. First one is thiazole. 1, 2, 3, 4 and 5. This is thiazole. And nitrogen is at position of number 2. 1, 2, 3, 4 and 5. This is isothiazole. Isothiazole. So, according to position of second heteroatom nitrogen is present at second position, it is known as isoxazole, and if nitrogen is present at number 3, position 3, then it is known as thiazole. So this is five-member ring, two or more heteroatom, simple heterocyclic compound. So, according to our syllabus, we will study about only thiazole, not for isothiazole. So, we continue with thiazole. First of all, we see preparation of thiazole. Preparation of thiazole. First, thiazole may be synthesized by chloroacetaldehyde and thioformamide. Chloroacetaldehyde, C double bond O, C bond H, CH2Cl. This is chloroacetaldehyde. Chloroacetaldehyde. And second compound is thioformamide, NH2CH double bond S. This is thioformamide. Thiazole may be synthesized from chloroacetaldehyde and thioformaldehyde. Thiazole, removal of H2O and HCl. So, when treated with chloroacetaldehyde and thioformamide, we get thiazole. We see second preparation. Thiazole derivative can be prepared by the interaction of thioamides. Thioamides. It is chloroacetone. Chloroacetone. CH2 IC-M-202C-L4.13. This is chloroacetone, and it is thioamide. This is alpha halocarbonyl compound. Chloroacetone is alpha halocarbonyl compound. And second compound we see thioamide, and this is thioacetamide. Thioacetamide. This is thioamide. So any alpha halocarbonyl compound and thioamide are interacted each other, then we get derivative of thiazole. And as for example, chloroacetone and acetamide are interact to each other, we get 2,4-dimethyl-thiazole. 2,4-dimethyl-thiazole. This is position 2 and this is 4. 2,4-dimethyl-thiazole. 2,4-dimethyl-thiazole. So any alpha halocarbonyl compound and thioamide gives derivative of thiazole. We have also one preparation number 3. Preparation number 3. By the interaction between chloroacetaldehyde and thiourea gives thiazole. Interaction between chloroacetaldehyde CHO-CH2Cl. This is chloroacetaldehyde, and thiourea, NH2CONH2, and here thiourea, so CSNH2, urea NH2CONH2. So interaction between chloroacetaldehyde and thiourea converted into 2-amino thiazole, and if we treated here, this 2-amino thiazole is converted into thiazole by two reactions. First of all, we takes place diazotization with the help of NaNO2 plus HCl at 0 to 5 degrees Celsius, and second, boil with ethanol C2H5OH gives thiazole. So interaction between chloroacetaldehyde and thiourea gives thiazole. These are the very important preparation of thiazole. Now we see the properties of thiazole. Properties of thiazole. Thiazole is a weak base. Thiazole is a weak base. It is in form of liquid, and liquid contains its boiling point. So boiling point of thiazole is 117 degrees Celsius. 117 degrees Celsius. Possesses aromatic properties and very stable compound. So thiazole is a weak liquid base compound having boiling point 170 degrees Celsius and possesses aromatic properties, very stable compound. Now we see the chemical properties of the thiazole. Chemical properties of the thiazole. When thiazole is treated with different types of reagent, then fifth position, the reacting group is introduced in sixth position and fifth position, and 5 reacting group thiazole is obtained. 5 reacting thiazole is obtained. If we takes place chlorination, chlorination takes place, then chlorine group is introduced at fifth position and we get 5 chlorothiazole. 5-chlorothiazole. If nitration takes place with the help of nitrating mixture of nitric acid and sulfuric acid in proportion of 1:3. So nitro group introduced at position 5 and we get 5-nitrothiazole. 5-nitrothiazole. If sulfonation takes place, then sulfonic acid group SO3H enters at number 5 and we get thiazole 5-sulfonic acid. Thiazole 5-sulfonic acid. We have one more important chemical property, that is ring open of thiazole. Ring opening properties of thiazole. When thiazole is treated with sodium and ethanol to form thiols and amines. When ring opening properties, thiazole is treated with ethanol C2H5OH and sodium in presence of ethanol. So ring open when thiazole is treated with sodium and ethanol to form thiols. That is, here ethanol is present, so ethanol thiol and methylamine is obtained. So we get CH3CH2SH. This is ethanol thiol. And we get CH3NH2, that is methylamine. So, when thiazole is treated with sodium and ethanol to form thiols and amines. Thiols and amines. These are very important chemical properties of thiazole. Here we complete according to classification of heterocyclic compound. Today we complete 5-member ring. 5-member heterocyclic ring containing one or two or more heteroatoms. Pyrrole, furan, thiazine, pyrazole, imidazole or iminazole, oxazole and this thiazole. These all are from one heteroatom or two or more heteroatoms. All are simple compound. Now we see the 5-member ring fuse compound. 5-member ring fuse compound. We have a second part for the 5-member ring compound, and we have 3 heterocyclic compound: indole, benzofuran and benzothiophene. These are 5-member fuse heterocyclic compounds. So we continue with our next compound, indole. Heterocyclic compound, indole. Heterocyclic compound, indole. It is also known as 2,3-benzopyrrole. 2,3-benzopyrrole, and we write down structure. This is fuse compound and benzo fuse. So pyrrole contains or combined with benzene ring is known as benzopyrrole. This is structure of indole. Structure of indole. Naturally, we will discuss in classification. Naturally, this indoles is occur in coal tar. Coal tar oil contains indole, and also in jasmine flower. Jasmine flowers and blossoms contains indole as natural component. We have some synthetic root also here. So first of all we see preparation of indole. Preparation of indole. First we see indole may be prepared from phenylhydrazone and acetaldehyde by the following this reaction. First of all we write down phenylhydrazone. This is phenyl ring and it contains NH2. This is phenylhydrazine. is treated with acetaldehyde CH3CHO acetaldehyde. Condensation takes place. NH N triple bond NH N triple double bond CH3 CH3 here from oxygen and two hydrogen remove, so H2O remove and we get phenyl hydrazone and acetaldehyde. This is, we write down this compound as also, it is similar to cyclic compound as similar to this. This is phenylhydrazone of acetaldehyde. Phenylhydrazone of acetaldehyde, and this compound is treated with zinc chloride ZnCl2 at 180 degrees Celsius, and loss of ammonia gives indole. When phenylhydrazine and acetaldehyde undergone by condensation, we get phenylhydrazone of acetaldehyde, and this phenylhydrazone of acetaldehyde heated at 180 degrees Celsius in presence of zinc chloride gives indole. So this is the synthesis of indole. Now we see second preparation. Second preparation is known as Fischer synthesis. Fischer synthesis. This is the most important method for the synthesis of indole derivative. It consists of heating the phenylhydrazones of aldehyde, ketones or ketoacids with zinc chloride, sulfuric acid, BF, polyphosphoric acid at about 180 degrees Celsius. So we get indole derivatives. phenylhydrazone derivatives. Phenylhydrazone derivatives of derivative of aldehyde, ketones or keto acids. So this is known as Fischer synthesis. First of all, I write down the phenylhydrazone derivative. This is phenylhydrazine derivative. Different types of derivative like aldehyde, ketone or keto acids. And we take here X as hydrogen, that is alkyl group of acid, alkyl group of acid, and R as hydrogen or alkyl group. So when this compound is treated with zinc chloride, sulfuric acid, fluorodoran, polyphosphoric acid at 180 degrees Celsius, then it is converted into derivative of indole. Derivative of indole. Indole derivative, and this is known as Fischer synthesis. Fischer synthesis. We have one more preparation for indole, and this is known as research synthesis. So we see the number 3 preparation of indole. Research synthesis. Indole may be prepared from orthonitrotoluene and ethyl oxalate by this synthesis. So we have starting material orthonitrotoluene CH3NO2. This is orthonitrotoluene and COOC2H5. COOC2H5. This is ethyl oxalate. And orthonitrotoluene. Starting material for indole is orthonitrotoluene and ethyl oxalate. So we get derivative of indole in the presence of sodium ethoxide C2H5ONA and removal of 2 mole of ethanol. We get derivative of indole. Derivative of indole. Now we treated or this derivative undergone by two reactions. Reduction takes place with the help of HCl and zinc acetic acid mixture. Zinc acetic acid mixture is converted into amino derivative. NO2 is converted into NH2. Remaining portion is as it is. And tautomeric reaction of this compound or tautomerization takes place. So position of hydrogen is transfer here to here. Tautomerism. So hydrogen is replaced by this position and convert into CH double bond C bond OH, and now it is dehydrated, so minus H2O, we get cyclic compound of indole derivative, and then it is treated by hydrolysis. First of all takes place hydrolysis with the help of HCl HCl hydrolysis, and second we takes place decarboxylation, removal of ethanol and CO2 gives indole. This is known as research synthesis. With the help of orthonitroaniline and ethyl oxalate, with the help of sodium ethoxide, and then reduction takes place. So nitro group is converted into amino group. Replacement of hydrogen gives amino derivative, and dehydration and then hydrolysis and decarboxylation gives indole. So this is the very important preparation of indole. It is known as research synthesis. Now we see important property of indole, and then both properties, physical and chemical, and then we complete our lecture, today's lecture. So first of all we see properties of indole. It is solid component having melting point 52 degrees Celsius. 52 degrees Celsius. According to nitrogen, it is weak base. And exhibit aromatic characteristic. And electrophilic substitution reaction According to the structure of indole, the numbering start from here 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9. So, electrophilic substitution reaction occur in position 3 or 2. Position 3 or 2 substitution. When nitration, bromination, sulfonation, etc. reactions take place. So the different groups are substituted in position 3 or 2. Position 3 or 2 in indole. So we see the basic chemical reactions of indole. I write down the structure in center. For electrophilic substitution, reaction takes place at these 2 and 3 position, 2 or 3 position. So when we treated halogenation with the help of bromine or iodine, then 3 bromo or 3 iodo-indene is obtained. Bromination or iodination takes place, then 3 bromo or 3 iodo-indole is obtained. It is undergone by nitration, nitrating mixture, help of nitric acid and sulfuric acid. Then we get 3 nitro indole. 3 nitro indole. According to electrophilic substitution reaction in position 3, 3 nitro indole is obtained. Sulfonation takes place. Sulfonation takes place. Sulfonic group. Sulfonic group, it enters as position 3 and we get indole 3 sulfonic acid. Indole 3 sulfonic acid. Now we see formylation reaction. Formylation reaction of indole. Formylation with the help of formaldehyde and hydrochloric acid. So 3-formyl indole aldehyde group enters at position 3. 3-formyl, this is 3-formyl indole. 3-formyl indole. So these are the basic reaction. of indole. Indole undergoes many reaction, give gramine product. That is managed base. Gramine product is known as managed base. So we see one more important chemical properties. Indole undergoes managed reaction. Indole, formaldehyde, and dimethylamine CH3 twice NH. It is dimethylamine undergoes many reaction, gives many base. CH2 and CH3, and this is known as a gramine managed base, gramine. So indole undergoes managed reaction, gives bromine product. These are the very important chemical reaction or chemical properties of indole. We stop here over this lecture. Okay, thank you.